कर दिया. All of you, good morning, good afternoon. I'm sorry about yesterday. Some of you must have come and gone, though we put up a message earlier. Yeah, I'm better. Just a bad cold and a flu. I was down. I'm still down, but I'm fine now. Yeah, Preeta, I will survive. Don't worry. If that's the concern. न पता है बोला नहीं जाता सर पैसे दे दिए अब आप नहीं रहोगे तो क्या करेंगे टाइप्स मैं भूत बन के ही पढ़ा दूंगा कोई बात नहीं okay so excuse me my bad cough otherwise we are good to go okay so we are joined by some of the new students also for this batch agriculture we are done I thought of discussing one aspects of Indian agriculture जो हम करा देंगे as a part of case study maybe. I've told Ajay sir to take it up. So today onwards we are starting with geomorphology, right? So most of you recognize geography as geomorphology. Okay. So when we start our courses with human geography, not all are very happy. उनको लगता है कि नहीं पहले तो लैंडफॉर्म जानना चाहिए पहले तो हमें क्लाइमेट जानना चाहिए okay so it's not like that but ठीक है we start with geomorphology so a couple of information here number one this is I think the longest unit of geography. It takes approximately 25 odd days to finish this off, right? So be patient with that. And in geomorphology, there are three parts. One is called as tectonics geomorphology. One is called as structural geomorphology. And a third part called as applied geomorphology. Okay. The tectonics geomorphology is largely the study of large scale forces. Okay. When I use the word tectonics, the root word is technique, technology. Okay. So it's something around how things are made. The technology kya hai? Is some processes that makes things, technology. Okay. So it's about the forces, large scale forces. Many of these forces have their origin in Earth's interiors. Okay. So tectonic geomorphology deals with the very large forces. Structural geomorphology is about landforms and the processes that shape them. Processes that shape them. And when I say processes means you have processes of the Earth's interiors and also have processes, okay, which are external. Wind as a force, glaciers as a force, rivers as forces. The word structural is about landforms. And देखा जाए तो both of these are linked to one another. Okay? And applied geomorphology, it's about solving human problems It's about planning. It's about managing disasters, landslides. Applied is all about how we can use the knowledge of geomorphology to benefit our lives, our living, our economy. Okay, so it's solving human problems, using geomorphology to plan for some things. Resources planning hua, planning for construction, planning for urbanization. Okay, so this is a quick look on the scope of this particular unit. Okay, so these three parts. Next one is, so geomorphology deals with what? Okay, it deals with all forces, all landforms, okay, that affect the Earth's surface and its features. When I say all forces, I am implying forces from the interiors of Earth and also forces from the Earth's exterior. Some of us know this as internal force and external force. Okay. Geomorphology deals with what? It deals with all forces. It deals with all landforms that affect a surface and its features. Okay? Applied, that's it. Abhirup. Structural and applied. I can move on now, all of you. So I'm just defining the scope of geomorphology. Now I want you to see the syllabus of geomorphology once, and I'll suggest you write it down too. If you all can see my screen here. Yeah, please note these terms down. Likho, ek ek karke likho. We start with geomorphology. Okay, keep writing, please. The first is origin and evolution of Earth's interiors. So, of Earth's crust. Origin and evolution of Earth's crust. And write 1, 2, 3, 4 of Earth's crust. Number 2 is Earth's interiors, the conditions of Earth's interiors. And number 3 is continental drift. Continental drift. Third is plate tectonics and all the forces. The first is origin, evolution of Earth's crust. Number 2 is conditions of Earth's interiors. Number 3 is continental drift. Then we have tectonics and all the forces. The fourth is mountain building. Note that the entire phrase, the key phrases, mountain building, and very specifically it says recent views. There are many theories in this. It very specifically mentions recent views. Then we have channel morphology. Then we have geomagnetism. Channel morphology, geomagnetism. Then it says factors controlling landform development. Factors controlling landform development. Earthquakes and tsunamis. Earthquakes and tsunamis. Slope development. Slope development. Geomorphic cycles and landscape development. Slope development, then geomorphic cycles and landform development. Isostasy, erosion surfaces, erosion surfaces, geosynclines, denudation chronology, ये अलग है terms, okay, इससे कॉमन ही है. Denudation chronology, volcanicity, and under applied geomorphology, ये एक term है. Applied geomorphology, 3 parts. Applied geomorphology and geohydrology. Applied geomorphology, economic and environment. Economic geology and environment. And as a habit, I have insisted all of you please make sure that you are familiar with syllabus always, right? All done, all of you? Online, offline, लिख लिया आप लोगों ने, all of you? Okay, good. Okay, so let's get back now. So if you look at your syllabus, tectonic geomorphology, structural geomorphology, and applied. Applied you have seen, it includes economic, it includes environmental, it includes geohydrology. Structural one has slopes, landscape development, something called as erosion surface, denudation chronology, okay, landscape development, and also landform development. I'm dividing your syllabus under the 3 heads I've told you. अप्लाइड बता दिया आपको मैंने, इकोनॉमिक जियोमॉर्फोलॉजी, एनवायरनमेंट एंड जियोहाइड्रोलॉजी. The structural geomorphology is slopes, landscape and landform development, a topic called erosion surface, and a topic called as denudation chronology. And tectonic geomorphology is everything else. Okay, earthquakes, volcanism, plate tectonics. It includes mountain building, continental drift theory. All the rest is there. Why I'm telling this to you is because this is a very large unit. Okay, and you must know which sections to focus on. If you look at the questions, every year they're asking more questions here. Questions on this reduced for some time, again ye बढ़ा रहे हैं. Okay, so I have a sense of that. So when we finish the syllabus, I'll see the questions also, but have a sense. This is one topic which can completely trap you otherwise. Okay, geosyncline tectonics comes into this. Tectonics and geosynclines. Okay, geosynclines will be more on the structural side, and tectonics I mentioned is okay the tectonic geomorphology. Okay, your book for reference is this one book I recommend everybody, Geomorphology by Savindra Singh. I have an older version, but you can buy the new one. So, Geomorphology by Savindra Singh. There are 4 books I will need. Geomorphology by Savindra Singh. इसके बाद में I will need Climatology by Savindra Singh, Oceanography by Savindra Singh, and also Environment Geography by Savindra Singh. You must buy all the 4 books as separate books. एक और किताब आती है Physical Geography by Savindra Singh. Physical Geography by Savindra Singh. Don't buy this one. All the 4 books, they have taken some section from here, something from here, something from here, and combined them into one book. This book will not solve your purpose. अगर है तो अच्छी बात है, रखो उसको. But for references, I need these books. So that's your choice. You want to buy all the 4 together or one by one? That's your call. अभिरूप, आप हमेशा एक कदम आगे ही होते हो बच्चे. So no worries. ठीक है, and I'll recommend class 11th fundamentals of physical geography, the NCERT book, for quick revision of GS based questions. I always say this to all of you, NCERT books are the best books except for geography books. Okay, and I can't blame them either because geography concepts are technical concepts. So what happens is it becomes difficult for them to cover everything in the NCERT. NCERT is a good book for revision. आपने पढ़ लिया, समझ लिया है, for geography in particular. Then you revise to understand NCERT is better. Okay. So while I am teaching this topic in the class, in parallel you can do once I finished one particular topic of discussion. Okay. Okay. You also have Savindra Singh, physical geography, Shweta. Okay, so your best friend Abhirup also has that. Okay, find one more friend you can sell it to. हाँ भाई, ऐसा कुछ नहीं है बेटा. Okay, एक महीने एक पिज्जा मत खाना, उतने पैसे उठ जाएंगे आपके. ठीक है? No worries. Okay, so we start off now. So before we start off, certain general facts, general figures and general appreciation. Those who are starting with me today, okay, ठीक है, Dolly, fine. 2-3 caution things. One is, please get used to my work of art called handwriting. Okay, हर बैच के पहले मुझे बोलना पड़ता है, and this is the biggest learning for you. What happens if you do not write clearly? Okay, you will become teachers. Okay, so it's a God sent message to all of you कि अच्छे से लिखो, साफ से लिखो, और क्वालिफाई करना है. ठीक है? So don't needle me on this. It's already traumatic for me. Okay, so we'll try forgetting that. One. Number two, you will write as I speak. Okay, it will take you some time to get used to it, but eventually you will get a hang. I'll dictate some things. I will ensure you don't miss out the points, but try writing as I speak. And if you miss something, don't lose heart. I will repeat everything. I repeat 2 or 3 times. If you are careful, आप miss नहीं करोगे. And while writing, one technique is, if कोई एक word समझ में नहीं आ रहा है, leave a space and move ahead. When I repeat again, वो वापस आ जाएगा word. ठीक है? So that's an important note there. One. Number two, everything on the board must be in your notes. I draw something, you draw. I write something, try writing. Okay, I have mentioned some book pages, whatever, you mention that also. Okay, so do not leave anything for later. And in the class, I want all of you to be writing consistently. And there's nothing called as fair writing. वो एक mistake बच्चे करते हैं. In the class, they do rough writing. I don't know what that means. And then back in their home, they do fair writing. Absolute waste of time. Back in your home, you should be doing summaries, not writing the whole class notes again. तो एक ही बार लिखना है. In the class, while the class pace goes on, write once. Okay, and if you miss out something, okay, you ask your friends or clarify afterwards. ठीक है? So we start off now. Quick facts. Our Earth is part of what we call as terrestrial planets. These are rocky planets. Mercury, Venus, Earth, Mars. These 4 are called as terrestrial planets. They are also called as rocky planets. In some books, they mention these as inner planets also. And Jupiter, Saturn, Uranus, Neptune. We leave out Pluto because planet tha, kabhi nahi tha, kabhi hai. So officially now we say Pluto is not a planet anymore. These 4 planets are called as Jovian planets. They're also called as gaseous planets. Okay, they are not Earth-like. So when I say terrestrial, we are saying Earth-like. When we say Jovian, I mean they are Jupiter-like. Okay, Jovian planets, they are largely gases. They have got very low density. They are very large, mostly. Khaskar Jupiter, okay, Saturn. When I say Earth-like, density, and they're mainly made of rocks. बहुत ज़्यादा gases नहीं है. Okay, that's why I'm calling them as terrestrial. Okay, their density is comparable to Earth. Earth का कितना density है? The average density of Earth about 5.5. Okay, and Earth is the densest planet. Earth is the densest planet in our solar system. So Earth is one of the inner planets. Earth is one of the terrestrial planets. It's a rocky planet. The densest planet, about 5.5 is the density. I don't add a unit here because these numbers are comparing Earth with water. The water is 1, Earth is 5.5 times denser than water. Okay. So that's why we don't have units here. We call this as specific density. You compare with Earth, with water. Okay. Unlike Earth, Jupiter is lighter than water. If there was enough water and I had put Jupiter, it would float. The density of Jupiter is less than water. Okay. So Earth is 5.5 compared to density of water. Okay, I'm moving on now. Now, Earth's interiors, what is its nature? Earth's interiors, what is its nature? When I said it is dense, and the interiors are layered. Earth is dense and the interiors are layered. So if this is Earth here, the composition varies, but the composition inside the Earth is not random. Light, very dense, very, very light, ऐसा नहीं है. Okay. Earth's interiors have a pattern, a layer of very dense rocks, very light rocks, a layer of bit more dense rocks, a layer of bit more dense rocks, the densest rocks. Okay. So Earth's interiors are not like this. They have layering like this. These are, we call these as concentric layering. All of them have one common center. Earth is dense, Earth has layered interiors, and it is concentric layering. Okay. And in this concentric layering, the pattern is that Earth gets progressively denser as we go inside. What this means is the outer layers are lighter and the inner layers are more dense. It becomes progressively denser, means the outer layers are relatively lighter and the inner layers have more density. Now this is one of the mysteries. Kaise hua kaise? Okay, there are many concepts here, but this is one of the mysteries. Why is Earth layered and why this pattern? Outer layer less dense and inner layers are the densest. Why? So one of the theories that explains this layering is a theory called as nebular hypothesis. Nebular theory. Nebular, N-E-B-U-L-A-R, nebular hypothesis given by Laplace. Laplace theory called as nebular hypothesis. In short, ये theory कहता क्या है? It says Earth was formed from gases that cooled and solidified, and because of, ये word use करेंगे, because of accretion process, while Earth was spinning. Earth was formed from, कहता क्या है? Earth was formed from gases. Earth was formed gases, and these gases are part of something called as nebula. Earth was formed from gases. वो gases हैं क्या? Some gas which has no shape, hydrogen, helium, it had lot of loose atomic particles. Okay. Nebula that cooled and solidified. The gas becomes solid, and there's a process called as accretion. Accretion means growth. Okay. And because of accretion process, while Earth was spinning, there was gravity collapse. There was gravity collapse, and the denser matter fell inside, and the outer layers became progressively lighter. Because of accretion process, while Earth was spinning, Earth घूम रहा है, Earth is spinning, a process called as gravity collapse, G-R-A-V-I-T-Y. In this process, what happens is the denser matter falls inside. What is heavy will go inside. and the outer layers are progressively lighter. The heaviest one, the very dense one inside, a bit less dense outside, a bit more less dense, okay, here, very light will be here, the lightest matter will be here. We call this process as gravity collapse. Generally, if you are spinning something, जब आप घुमा रहे हो उसको चीज, okay, you'll understand things fall outside, right? Okay, think of something like that. Earth is spinning, okay, and things are getting separated. We call this process as density differentiation. It's also called as the process of density differentiation. It's called as density differentiation. अर्थ का densities अलग अलग हो गया. The densities have got differentiated. The densities have got separated. Okay. So why Namrata? We just call it as the conclusion of nebular hypothesis. हम इसके आगे नहीं जाएंगे. Okay. So my escape here is I use the name Laplace. बड़े आदमी है, कुछ सही बोल रहे होंगे. Okay. एक बड़ा सा phrase use किया, nebular. I used one technical word, gravity collapse, and this process leads to density differentiation. That's all. I don't need more than this. We won't enter into astrophysics here. ठीक है? So this is, and remember, this is just one of the theories. और भी बहुत theories हैं. Some theory explain one part, can't explain another part. Some theory can explain one aspect, but to explain something else, I need some other concepts. Earth's origin continues to be one of the big astrophysics mystery. Abhi bhi I can't be very sure exactly how Earth was formed. Though we talk about the Big Bang theory, but Big Bang theory also has lot of discrepancies. It also has lot of errors and gaps. Okay. So if you look at any one theory, it will not be enough. Okay. There are a lot of theories put together. We won't go down that rabbit hole for now. बस हमें इतना ही जानना है. Okay. Earth is having layered structure, and the layered structure is a consequence of probably nebular process of gravity collapse that has led to density differentiation. Okay. So because of this, the layered structure है. The innermost layers are very dense. इसको हम कोर बोलते हैं. The density is more than 11.5, 13.5 times. The innermost layers are very dense. The outer layers, which we call as crust, this has a density of 3, 3.5, 2, 2.5. Okay. Because of the density differentiation, the innermost layers, which you call as core has a density of 11, 11.5, 13.5. The outermost layers, they are much less dense. 3.5 is the density of the ocean crust. 2.5 is density of the continental crust. The continents are lighter. The ocean crust is a bit more denser. ठीक है. Earth's composition Earth is majorly made up of heavier metals, iron, magnesium, nickel. Earth is majorly made up of heavier metals. Okay. Fe is iron, Mg is magnesium, Ni is nickel. But the outer layers have lighter elements. The outer layers have lighter elements. So if you look at Earth, अगर पूरा Earth देखोगे, lot of Earth is made up of these things. But if you look at the outermost layer does not have much of this. The outer layers have more of lighter elements. Reason वही है, because of density collapse, the heavier ones have gone inside and the lighter ones have stayed outside. Okay, so outer layers are made up of lighter elements. The crust has oxygen, silicon, aluminium. Okay, some amount of iron. The outer crust में जो ज्यादा amount है वो oxygen है, silicon है, aluminium, and all these three are lighter. The crust does not have much of magnesium. It has less amount of iron. ठीक है. What is Earth's composition? Earth is, so when I say majorly, I'm talking about the whole of Earth. If I look at the entirety of Earth, पूरा Earth देखेंगे अगर आप, it has majorly heavy metals. But these are more in the deeper layers. Okay. The outer layers, the crust is what? The crust is the outer layers. The outer layers are made up of this, and these are the lighter elements. They are lighter elements. Okay. Next fact. The most common group of minerals in the Earth's interiors is silicate minerals. The most common group of minerals in the Earth's interiors is silicate group of minerals. By the way, ये जो word mineral है ना, there are two meanings to this. One is the economic meaning. which basically means all resources mined from the earth. जो mining करते हैं, coal is a mineral, oil is also a mineral, gold is a mineral, lithium is also a mineral. हम जो भी mining करते हैं, that is the economic definition. India's mineral resources, हम जो भी mining करते हैं, graphite is a mineral. Okay, whatever I'm mining from the earth, I make a hole, I dig out, वो mineral हो गया. और एक है the geological concept, ये दो अलग चीज है. The geological concept is minerals are naturally occurring compounds. Compounds mostly. They can also be metals. They are naturally occurring compounds. And इस compounds के तीन property हैं. Minerals are always crystalline. They'll have crystals. Minerals have fixed structures. Arrangement बहुत fixed होता है उनका. And they are mostly inorganic, means they're not from life forms. So the meaning of mineral varies in economic terms and in geological terms. No, Shweta, minerals are not in native form always. When I say native form, I mean pure metals are like, so gold is a native form, or platinum is a native form. Okay? So this mineral is the geological one. When I say minerals, I do not mean the minerals that we have like we are mining. The coal is a mineral if I go by resource. But actually coal jo hai, it is a rock, not a mineral. So if you look at geological sense mein, it is elements. Elements will create compounds called as minerals. Minerals will create rocks. Okay. Minerals are compounds. So minerals will have fixed properties. Melting point, boiling point, color, texture, hardness, उनके fixed होते हैं. Rocks are mixtures. Rocks are not compounds. Rocks are mixtures. Marble of Rajasthan is not same as marble of Jabalpur. Coal of Damodar is not same as coal in parts of Narmada. Can you all hear me well? Satyam, online students, am I streaming fine? Arun, ये कहां से गिरा दिया आपने? You have backlogs, okay. उसको साइड रखो फिर अभी. It's fine now? Okay, come back. So my discussion point was that the most common group of minerals in the Earth's interiors are a group called as silicate minerals. And minerals क्या हैं हम समझा रहे थे आपको. Some examples of other groups are, we can have carbonate minerals, we can have oxide minerals, we can have halide minerals, we can have sulfate minerals, we can have sulfide minerals. हम कह रहे हैं कि Earth has more of what? Silicates. Silicates are essentially compounds of silicon and oxygen. Okay, the Earth's interiors has majorly silicate group of minerals. Silicates are silicon and oxygen compounds. Other groups are these: carbonates, oxides, halides, sulfates. Okay? So these are there, but the bulk is silicate, not these. Okay, the bulk of the minerals are silicates and not the carbonates, other groups. We move on. Now, silicate groups में of minerals, there are lighter silicates and there are heavier silicates. The lighter silicates are called as non-ferro-magnesium silicates, and these are called as ferro-magnesium silicates. Short में NFMS and FMS. Silicates में there are lighter silicates and there are heavier silicates. Okay. Non-ferro, they don't have iron, they don't have magnesium. Ferromagnesium means they have iron, they have magnesium. Both are silicates. So the lighter ones, these are found in the outer layers and the crust. These are found in the deeper layers. Some of you might know what's called as mantle and the core. Forget the core, just write mantle. There have been no questions on this, and I don't think they will ask you. But without these concepts, you can't understand the other dimensions of Earth's interiors. Okay? I'm going back to our discussion where I said the inner layers are dense, the outer layers are lighter. The inner layers are dense because they have got ferromagnesium silicates. The outer layers are not dense because they have non-ferromagnesium silicates. मुझे बस यही जानना था. What makes the outer layers dense is the non-ferromagnesium silicates. What makes the inner layers dense is the ferromagnesium. What makes the outer layers less dense? It is non-ferromagnesium silicates. Okay? So when you talk about the nebular accretion, the outer layers, no, it was such that the denser matter became the inside and the outer layers are less dense. So outer layers to less dense है. ये less dense क्यों है? Because they have non-ferromagnesium silicates. And the inner ones are more dense. Why? Because they have ferromagnesium silicates. That was our discussion point. Is this okay, all of you? इसका एक और नाम है. Okay. These lighter silicates, lighter हल्के वाले हैं. We also call these as felsic. And the heavier ones we also call as mafic. They're also called as felsic, and the heavier ones are called as mafic. So the outer layers, I said crust. The inner layers, I've called them as mantle. The crust is felsic. The mantle is mafic. The crust is non-ferromagnesium silicates. It is ferromagnesium silicates. याद रहेगा आपको? There's more nuance in this, but to start off, I'm starting here. Abhirup, I am ignoring your questions, okay? I'll answer when the times come to it. अभी आप, okay, चुपचाप याद रखोगे अभी आप. You just remember these facts. Earth is a terrestrial planet. Earth is a rocky planet. Earth is the densest planet. Earth is layered. The outer layers are lighter. The inner layers are denser. The process was nebular accretion, in which the outer layers became lighter. The inner layers were denser. The outer layers are lighter because they have non-ferromagnesium silicates. They have felsic type of material. The inner ones are denser because they are ferromagnesium. They are mafic. ये आपका facts बताया मैंने आपको. Revising quickly. Earth is a terrestrial planet. Earth is a rocky planet. Earth is layered because of nebular process of accretion in the layer. The outer ones are lighter. The inner layers are heavier. Lighter because non-ferromagnesium silicates. Felsic. Ferromagnesium silicates. Mafic. इतने बताया आपको मैंने. Fine till here? The cough sounds worse than it actually is. No? It's a dog's bite type. Okay. The bark is worse than the bite. Okay. It almost looks like I am collapsing, but I am not. Yeah, so for us, Satyam, silicate groups are more important. Okay, we'll not go beyond this right now. Okay, so we'll keep it. Okay, ठीक है. लिख लो margins में. I didn't want to go there, but अब पूछ रहे हो तो मरो. So NFMS or felsic, we have minerals like quartz, feldspar, orthoclase and ferromagnesium silicates जो मेफिक वाले हैं, एम्फीबोल, pyroxene and olivine. एक दो और है बीच वाले, like transition ones called as biotite, called as muscovite. ये transition minerals है. They want लिख लो और क्या. As a part of initiation, Ajay sir would have completed this for some of you. Okay. If not, just remember this much. That's it. What are the examples of NFMS or felsic rocks or minerals? Sorry. These are minerals. These are all silicate minerals. Quartz, feldspar, orthoclase, 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 and FMS minerals are amphibole, 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 pyroxene, 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 and olivine, OLIVINE, olivine. Or transition minerals are biotite and muscovite. Okay, you don't need to know this in details, but okay, it helps you clarify something, that's okay. Any doubts in these points, anybody? So now I give the names also, which are the felsic ones, which are the mafic ones. And remember, the crust is lighter. The composition of the crust is oxygen, silicon, aluminium, then some bit of iron also. But the abundant elements in the outer layers are these. These make up bulk of the composition of the outer layers. All done? Okay. So, conditions of Earth's interiors. One is discussing the composition. What type of minerals बता दिया मैंने. Discussing density variations. It becomes denser with depth. Okay. Lighter outwards and denser inwards. A third discussion is temperature variations. Conditions of the Earth's interiors. I've discussed composition in brief. I've discussed density variations in brief. It becomes denser as I go inside. Okay. The arrangement is layered. The arrangement is layered. All done? I'm looking at this particular topic. The physical conditions of the Earth's interiors. ये बता रहे हैं आपको. What does the interiors of the Earth look like? Fatima, I'll take up that. Wait, one by one. So composition बता दिया, density बता दिया मैंने. Now come towards temperature variations. Now in temperature, temperature variations. In general, the interiors become hot they become hotter with depth. As they go inside, it becomes more and more hot. The interiors become hot or hotter with depth. इसका रीजन क्या है? Why the interiors are hotter? One reason is the heat is what's called as residual heat of the nebula. Okay. What is nebula? Nebula is the ancient cloud of gases. Nebula is the ancient cloud of gases. And it was very hot. When Earth was formed, the nebula became cold. Reason is the heat is the residual heat. Okay. Some amount of heat has still remained in the interiors. पूरे का पूरा ठंडा हुआ नहीं है. In time, Earth will become even more colder. But some amount of heat is still trapped. The heat of the nebula. The nebula is what? It is an ancient cloud. बहुत पुराना cloud है. Okay. It's a cloud of gases and it was very hot. When Earth was forming, the cloud was becoming cold. लेकिन पूरा cold हुआ नहीं. Some books they write this as, they also call this as the residual gravity heat, जो trapped inside. Okay, one. Second is because of radioactive reactions. The lot of fusion reaction happening, lot of fission reactions happening. Inside the Earth, you have got radioactivity going on. Okay? So these two are the sources of the Earth's interiors. Yes, sir, Ashish, correct. Heat from radioactivity and heat which is the residual heat from the interiors of the Earth from the nebular sources. There is no fixed pattern of the heat variations. There is no fixed pattern in the heat variations. Write 2-3 points here. Number one, at locations of tectonic activities, at the locations of tectonic activities, the temperatures can exceed 1000 degrees centigrade. At locations of tectonic activities, the temperatures can exceed 1000 degrees centigrade. What do I mean by tectonic activity? जहां पे volcanism है, जहां पर earthquakes हो रहा है, somewhere there is what's called as plate interactions going on, some activities going on. Those locations, the temperatures are more than 1000 degrees centigrade. Number two, in the deeper mantles, beyond 500 to 700 kilometers. In the deeper mantle, beyond 500 to 700 kilometers, the temperatures can be between 1500 to 2000 degrees centigrade. तो 500 किलोमीटर के beyond 500 kilometers, beyond 700 kilometer, temperatures can be around 1500 to 2000 degrees centigrade. Third, at the core mantle boundary, at the core mantle boundary, so I'm talking about 3000 kilometers depth, kilometer depth. The temperatures can be at around 3000 degrees centigrade. At core mantle boundaries, it can be about 3000 centigrade. And the fourth one is at the core of the earth. Okay, this is more than 4000 kilometers ka depth. The temperatures can be 5000 to 6000 degrees centigrade. At core, at depths more than 4000 kilometers, the temperatures can be 5000 to 6000 degree centigrade. Okay? So otherwise there is no pattern as such. Okay? It varies from place to place. The temperatures of the Earth's interiors. I've taken care of, okay, the composition, density and temperatures. The three topics are done. Shweta, we'll come back to all those topics baad mein. Okay? We'll just know the interiors for now so that we have enough content to appreciate the interiors. Details, I'll come to it. Next slide down. Next, इसी का एक और component है the structure of the interiors. This is a bit more detailed discussion. The structure of the interiors. The structure means the arrangement. The arrangement of the layers. If they ask you a question on what is the conditions of the interiors, आपको ये चारों लिखना पड़ेगा. क्या composition है बताओ quickly. Tell us the density variations. Tell us the temperature variations and tell us the structure or the arrangement of the interiors. The bigger part must be here. All of this you can finish off quickly. This is the main discussion. Even for the GS you need more of the structure part. So take a fresh page if you can. Otherwise, ठीक है. The structure of the interiors. How is the interiors arranged? What are the layers and their conditions? The structure of the interiors. How is the interiors arranged? What are the layers and what are the conditions? All keeping pace with me? Online, offline? The new students all keeping pace. I had one request yesterday about, it would help if I spoke more in Hindi, but beta, ye course is in English. If I'm using Hindi, that's a mistake. I cannot use Hindi to explain. वो English वाला course बन जाएगा फिर. Okay. So I don't think I can do that. Anybody else has a language problem, you have to be managing with me. No, Mehul. You will not make separate notes of the book. You will make notes of the class and you will add whatever you can from the book in the main notes. So don't make a separate note for the books. Do it. I mean, as long as you are writing, I have no problem. Because even if you are late in submitting, kar do fir bhi. Summary is provided, yes, we'll give you something of the class, but I'll expect that you do the writing on your own first with me, rather than depending on what we give you after the class. I can move on. Any doubts on this? Anybody? So some new words. What is felsic? What is mafic? Okay, what do I mean by silicates? What are minerals? And some names like amphibole, pyroxene. Oh, no, I won't. Don't worry. I'll keep to English. Don't worry. All of them have got spooked out now. Yes. I'm absolutely convinced about that. I'll keep to English. And those who have a Hindi problem, okay, don't worry. Chalo, we continue. So now, Earth's radius is approximately 6400 kilometers. Okay, it's a large planet. It is impossible to enter the Earth physically and confirm the interiors. Information about the interiors is largely through indirect methods. Okay. We do have a movie called as Journey into the Earth. Okay. Oh, so fantasy wale hai. But what we know about interiors is largely through indirect methods. We observe something, we interpolate, we infer. Okay. Because of this, there have been many models detailing Earth's interiors. Different people have told us different things about the Earth's interiors. And remember, this is still a question not answered 100% accuracy के साथ. Abhi bhi we keep discovering something new. So Earth is a large planet, a radius of 6400 kilometers. We can't go inside and see physically. So what we know is by indirect inferences. So volcanic eruption hua, I study that. Some earthquake waves, I study that, and I try to know about the interiors. So there have been many models. Okay. So one of the earliest models was given by Edward Suez. Edward Suez model. He said outer layers, intermediate layers, and the innermost layers. Edward Swiss said the outer layer, he called it as the Sial layer, equivalent to the continents. Intermediate he called as the Sima layers, equivalent to the oceans. And the innermost layer he called as knife, equivalent to the core of the earth. Okay. Most of you have heard about this. NCERT books talks about this. The outermost layer of earth is Sial. Then we have a layer called as Sima. Sial is short form of silicon and aluminium. Sima is short form of silicon and magnesium. Knife is short form of nickel and iron. Edward Swiss ने ये term use किया था. It's a very old concept. In contemporary geography, we don't accept this anymore. But this was a model. The outermost layer was Sial. The intermediate was Sima, something like the oceans, and the innermost was core. Then we had a model given by Arthur Holmes. Just know these names, okay? You don't have to go too deep into this. Arthur Holmes model. Arthur Holmes said the outermost layers, he called it as grandiorite layers. Grandiorite. Basically, granite and diorite rocks. These are lighter rocks. Grandiorite layers. The next layer he called as amphibolite layers. AMPHI, amphibolite, amphibolite. And the innermost layers as echolgite layers. All based on compositions. Grandiorite, amphibolite and echolgites. This was the model of Arthur Holmes. We had one more model, Daly's model. He simply called these as outer silicates, the intermediate silicates, and the inner silicates. Okay. He said the outer silicates up to 1600 kilometers, density of 2.3 to 3 was density. This was around 1300 kilometers ka thickness, density of 4.5 to 9, and this had a thickness of 700,000 kilometers and a density of 11. ये thickness है, depth नहीं है. How thick the layer? Okay. 1600 kilometer, density of 2.33. The thickness is 1300, 1500 kilometer thickness, density of 4.5 to 9, and this was the thickness of 7,000 kilometers. Is it okay, all of you? Daly said this. Now, one variant of Daly is called as Van de Graaff's model. Grachats. Grachts. ठीक है. VANDERGRACHT Van de Graaff's model. So Van de Graaff's model में, write down, we have outer silicates, जिसका thickness will be about 60 to 80 kilometers, density of 3, and this is largely continents. Thickness of 60-80 kilometers, density is 3, and it is largely continents. The intermediate one, he said there are two layers here. One is called as inner silicates. This about 60 to 1000 kilometer thickness, density of 3, about 4.75, and there is one more layer called as mixed silicates. Which is beyond 1000 kilometers up to 2900 kilometers and a density of 4.75 to 5. A layer called as inner silicates and a layer called as mixed silicates. And the innermost one he called as the core. This was beyond 3000 kilometers, density approximately about 11, and this was pure metals. This is pure metals. It is like this. One layer, another layer, a third layer. This is the outer silicates. ये thickness होगा 60-80 kilometers. This is largely, he said, continents. फिर ये layer है. This is the inner silicates. So from approximately 60 up to 1000 kilometers. Density of 3, 4.75. Then this one. Okay. From 1000 to approximately 2900 or 3000. We call this as mixed silicates. And this is the core. The core is beyond 3000 kilometers. Make sense, all of you? The outermost silicate layer 60 से 80 ये continents है. 60 से 1000 या 80-1000, this layer is inner silicates. 1000 to 2900 or 1000 to 3000 is the mixed silicates. And this is the core. Core is beyond 3000. outer silicates, inner silicates, mixed silicates, and the core. All done? What's that, Vanshika? I said beyond 3000 kilometers. Density approximately 11 and more. And it is pure metals. This is called as the core. Core beyond 3000 kilometers का depth. Thickness आप बताओ. Okay. यहां से यहां thickness होगा ये वाला. ये thickness होगा ना. You must know the radius for this. ठीक है. So look at this. Say this thickness, this is say 100 kilometers. Say this is 350 kilometers. This is 2900 kilometers. I'll say the first thickness 100. ये कितना होगा? Thickness कितना? 350 minus 100. This is 250 kilometer thickness. ये कितना thickness होगा? It will be about 2300 kilometers or 2550 kilometers. The thickness means इसको minus कर दो. And depth का मतलब है यहां से यहां तक ले लो. ठीक है? So this is 2900 kilometers, and say the Earth is, radius of the Earth is 6400. 6400. तो ये अगर 3000 मानता हूं मैं, ये थिकनेस कितना होगा? 3000 and 3000 here, almost 6000 kilometer thickness हो गया. Thickness means okay, the difference of height. I can write both the ways. यहां पर ये लिखा है in terms of the depth. All done here? All depth, Fatima. ये सब depth बता रहे हैं आपको. All depth. Up to 2900 kilometer depth. This is up to 80 kilometers depth. And you measure depth from the surface. Add one point here. Van de Graaff's model is very close to the contemporary model of Earth's interiors. I said no, inner layers are difficult to know because you can't reach it physically. So different people have different models. And I'm saying Van de Graaff's model is the closest to what we know today. Others more like an academic thing to know what others have talked about the Earth. So now, what is the contemporary model? What is the contemporary model? So, there are two models. One is called as chemical layering on the basis of composition. Other is called as mechanical layering on the basis of rigidity or hardness. There are two types of models for how we see the Earth's interiors on the basis of chemical layering. The chemical layering means in terms of the composition, minerals, metals, what are the compounds, what are the rocks, the chemical layering. And one on the basis of hardness or rigidity. ठीक है? I'll discuss this one first. What is Earth's chemical layering? What is Earth's chemical layering? आपके GSC वाला part है. The remaining part, these discussions we don't need in GS. ये जो table बताया आपको ना, this is more like an optional study. You must know the names. For GS, you not know all the details. For GS, you need this one, which are almost all talk about. The layers are core. The outermost layers are the crust. Then we have the mantle, and then we have the core. Crust is the outermost and the core is the innermost. ये crust जो है, this is the thinnest layer, this is the lightest layer, and also is the youngest layer. Recently बना है. The thinnest layer, the lightest layer सबसे हल्का है, and it is also the youngest layer. The crust is of two types: the continents and the oceans. The continents density is 2.5. It is hard. It is light. It is acidic. Hard continents, lighter है, हल्का है, acidic है, and the main rocks are granite rocks, a very common rock called as diorite rocks, one more common rock called as andesite rocks. Continents are less dense, continents are lighter, they're harder, the pH value is acidic, and the main rocks are granite, diorite and andesite. And the continents, they generally are around 60 kilometers thick. In some places, they may be 80 kilometers also. They generally are 60 kilometers thick. The oceans, density of 3.5. Ocean comparison में, they are denser, they are basic, and the main rock of oceans are basalt rocks. And oceans generally are 1 to 2 kilometers thick. In some cases, they can be 3 kilometers thick. Oceans are thicker, continents are thicker, oceans are thinner. Continents have a thickness of 60. They can be 80 also. Oceans generally are 1 to 2 kilometers thick, but they can also be 3 kilometers thick. In any case, this is much less than the continents. But continents are lighter, oceans are denser. Continents are acidic, oceans are basic. Continents have granite rocks, diorite rocks, andesite rocks, and oceans have basalt rocks. Okay? That's about the crust. About the mantle. This is approximately 80% of the earth in volume and 60% of earth in terms of mass. The bulk of the earth is mantle. 80% of the earth in terms of volume and 60% of earth in terms of the mass. It is up to 2900 kilometers depth. तो फ्रॉम क्रस्ट के नीचे से 2900 किलोमीटर तक it is mantle. Mantle has 3 parts: the upper mantle, the middle mantle, and the inner mantle. Upper mantle up to 350 400 kilometers. The middle mantle up to 700 900 kilometers. And inner mantle up to 2900. All depth, not thickness. Surface से depth. Surface से depth. Surface से depth. Upper mantle up to 350 400 kilometers depth. Middle mantle up to 700-900 depth, and inner mantle up to 2900 depth. This has a density of approximately 4 to 5. This has density of 7 to 9. And this has density of approximately 9. The densest one is the inner mantle. Upper mantle, middle mantle, and the inner mantle. The most common rock, बहुत सारे variants हैं. Okay. The most common rock is a rock called as dunite. The most common rock is dunite. And the most common mineral is olivine and its variants. The most common rock is dunite, and the most common mineral is olivine, and its variants, its variations are there. Asha, middle mantle. Okay, 400-700 is middle mantle, and then we have inner mantle. Okay, that's about the mantle. The core, this is beyond 2900 kilometers. It has two parts, the outer core and the inner core. Outer core up to 4800 kilometers. The outer core is fluid, density of approximately 11. The inner core is solid, density approximately 13.5. The outer core is fluid, 11 density. The inner core is solid, 13.5. The right word for this fluid medium is something called as plasma state. Plasma state with loose electrons. Plasma state with loose electrons. Okay. So we'll draw afterwards. Just know this. देखो. The outer layers are oceans. Ocean water hai. This is the ocean crust. And then we have continents crust. Continents, I said, around 60 kilometers, 80 kilometers. Oceans are thinner. Beyond the ocean, there is this layer called as upper mantle. Then we have part called as middle mantle. We have part called inner mantle. So from here to here, the whole thing is mantle. The outer core and inner core. So if I put values on this, if I measure from top, this is approximately 4800 kilometers from the top, where the outer core starts from the top about 2900 kilometers, where this is there from top 700 या 900 kilometer. This part is middle mantle, about 350 400 kilometer. The thickness of the continents 60 to 80. The thickness of the oceans 1 to 2 kilometers. So I'll draw again, but just have a sense of the structure. Most of us know this. We'll just put it as a part of one sketch. And this I'll come back afterwards on what are these layers. Okay, so if I'm drawing this, so we have a thin layer of oceans and we have a thicker layer of continents. Then we have upper mantle, we have the middle mantle, we have the inner mantle. This is oceans, this is continent. Continents, I said, about 60 kilometers. They can go up to 80 also. and the oceans are thinner, 1 to 2 kilometers. ये जो है measure from the surface 350 40 kilometers, measure from the surface 700-900 kilometer, measured from the surface 2900 kilometers. This is the inner mantle, middle mantle, upper mantle. Outer core, again measured from the surface 4800, and this is the inner core. Can you all draw this, please? Do this, Dolly, I'll explain again. These numbers must be in your fingertips. Middle mantle, Asha. MM is middle mantle, IM is inner mantle. Outer core, inner core. संजय श्री, मैकेनिकल डाउट पूछ दिया आपने. I'm taking a slice like a pizza. ये कितना है? From surface. Is Earth radius, right? 6,4. This is your Earth. This is the center here. I've taken a slice like this. ये निकाल के आपको हम दिखा रहे हैं यहां पर. Okay, so ocean, continents, outer mantle, inner mantle, middle mantle, outer core, inner core. I've taken a slice like this. और center तक कितना है depth? 6400 kilometers. ये क्वेश्चन जो परेशान कर रहा है आपको, डेप्थ एंड थिकनेस. ओके, इसका क्या थिकनेस है? दिस इज 400 माइनस द अपर पार्ट. ये थिकनेस हो गया इसका. इसका क्या थिकनेस है? ओके, 400 माइनस 900 और 100, ये थिकनेस हो गया. ओके, इसका क्या थिकनेस है? 700 माइनस 2900. द थिकनेस ऑफ दिस इज approximately 2000 kilometers. 2900 माइनस 900 कर लो या बोलो, या फिर 2300 बोल लो. इसका क्या थिकनेस होगा? 4800 माइनस 2000. Okay, this is a thickness of what? Okay, 2800 thickness. इसका क्या थिकनेस होगा? What thickness of the inner core? Inner core is ये पूरा. इसका थिकनेस क्या होगा? This plus this, 6400 minus 4800, approximately 2000. इधर भी 2000, यहां भी 2000. This diameter is approximately what? 4000 किलो थिकनेस हो गया ये वाला. Make sense, all of you? That's how you calculate. 24, yeah, 2400. No, 1800. माइनस कर लो ना इसको. Into 2, the thickness here. So you remember either ways. Okay. So कोर का थिकनेस की बात नहीं करते हैं हम, कोर का बस बता देते हैं डेप्थ. बाकी थिकनेस इज द डिफरेंस ऑफ द हाइट्स. ठीक है, all of you done? On this diagram, you can put some details here. Middle mantle, okay, olivine rocks, minerals. This is andesite, granite, diorite, basalt. Okay, outer core is fluid, plasma state, and so on. You can have some detailing there. Add one point here. The arrangement of the core. The arrangement of the core where the outer core is very hot or fluid, plasma state with loose electrons, and inner core is solid and iron rich. ये जो arrangement है of the core, outer core is hot, it is fluid, it is plasma state. Plasma state means there is loose electrons, and the inner core is solid, iron rich. This is responsible for Earth's geomagnetism. This arrangement is responsible for Earth's geomagnetism. What this means is Earth behaves as a magnet. और यही रीजन है. The arrangement of the core, where the outer core is hot, fluid, plasma state with loose electrons, and inner core is solid and an iron rich. It's responsible for Earth's geomagnetism, responsible for Earth's magnetic property. Basically, physics में ये concept है. In physics, we have a concept when electricity is, or when there is a rotating, when there is there is a electric field, rather, an electric field around a magnetic iron core, magnetism will be produced. If you know something about what's called as solenoid, ऐसे अगर आप वायर को लूप कर देते हो and you pass some kind of electricity, and this is an iron core, you start behaving like a magnet. You know, we call this as solenoids. Something like what's called as electromagnets. अगर electricity है around one iron core, this behaves like a magnet. Okay, basic principle of physics है ये. Yeah, Fleming's right hand rule, left hand rule, and so on. So यही हो रहा है अर्थ में. अर्थ में क्या है? The innermost one is iron, and there are loose electrons, and these electrons are moving. These moving electrons create electric field. The electric field around an iron core, this creates a magnet. So Earth behaves like an electromagnet, essentially. This is the conclusion. Earth behaves like an electromagnet. All done? कौन सा ये वाला slide? ये वाला slide. You want this one? Yanu. The arrangement of the core, where the outer core is very hot, fluid. Plasma state means there are loose electrons and these can move. And inner core is solid, iron rich. If there is an electric field around a magnetic iron core, magnetism is produced. So this iron is capable of getting magnetized. We'll have magnetism. No, Abhay, no. This was the chemical composition. I hope you know where we are. हम ये वाला बात कर रहे थे. The chemical layering of the earth. The chemical layering is, there is a crust, there is a mantle, and there is a core. Yeah, anybody else? Any doubts on this? पूछो. So these topics are very dense topics. Dense means का मतलब क्या? I am pumping lot of things in one class. That's because इस पे question नहीं पूछेगा. But I want you to know these concepts. एक ही question पूछा था, and that too way back in just one question asked in 2005. वो भी indirect question था. Okay, the seismic wave study of interiors. Otherwise, I am tracking questions from 1986. No questions asked. ठीक है? Yes, the geothermal heat is linked to the residual heat, correct? But that's not the entire residual heat. Abhirup says, "Does क्यों फालतू में पढ़ रहे थे?" It's something like English language, you know. Is geography testing English language? But without the language, I can't teach you, you can't write. क्या लिखोगे आप? अभिरूप अगर ये समझाना पड़ रहा है तो खतरनाक है. ओके, फिर आप अलग जोन में हो. यूपीएससी में आना पड़ेगा, उतरना पड़ेगा, बहुत हाई लेवल पे हो. All done, all of you? Okay. So, let me see if I have the diagram with me or not. Not responding. Okay, this is a bit more simpler one, ठीक है? So, I'll share some of this with all of you. The crust, it says 570. ये 5 जो होगा ocean का part है, and this is the continent part. Okay, this is the upper mantle part. This is the middle mantle. Sorry, end of the mantle. There's one part missing here. The middle mantle, the outer core, and the inner core. Now, there are certain transition layers, bolo. Okay. Watch here. Say my palm with skin, my palm with skin, and I put them together. Okay, I fuse them as close as possible. But somewhere my right palm ends and the left palm starts. Or if I take a paper, okay, a paper and my palm, I put them together. I put them as close as possible. Yet, there's some place where the skin ends and the paper starts. So that layer is called as discontinuity. वो अलग से layer है नहीं actually. I hope you got the point here. वो अलग layer थोड़ी है. Essentially, some place, some location where the skin ends and the paper starts. So that transition where this change happens is called as a discontinuity. So वैसे ही inside the earth, okay, we will have such discontinuities. Where the crust ends, mantle starts. Where middle mantle ends, inner mantle starts. Where the mantle ends, the core starts. Okay. So those transition, okay, are called as discontinuities. Okay. So the Earth's interiors has discontinuities. Okay. These are depths where the layers get differentiated. Those interiors has discontinuities. A lot of books write as they are layers. They actually are not separate layers. They are not separate layers. ठीक है? They are depths where the layers get differentiated. So we have one. ऐसे बहुत सारे हैं. 3-4 of them we know. One is between the crust and the mantle. It's called as Mohs discontinuity. Then we have one between the middle and the inner mantle. We call that as birch or repeated discontinuity between the inner mantle and the outer core. It's called as Gutenberg's discontinuity. And we have one between the outer core and inner core. It's called as Lehman's discontinuity. I'm sure most of you have heard this. आपने GS में पढ़ा है. Actually speaking, I should not be teaching this to you. हम बस बता देते हैं GS में पढ़ लेना. Okay. But then it doesn't work that way. It's okay, online guys. Don't get emotional there. It's okay. Chat is on, so you can write whatever you want to write down. Moho discontinuity birch, birch, birch or repeaty, Gutenberg, Guten, Gutenberg's discontinuity, layman's discontinuity. एक और है, you should know geography optional. Inside the continent at around 30 kilometers depth, ये सिर्फ continents में होता है. It separates the upper continent from the lower continent. It's called as Conrad's discontinuity. It's called as Conrad, C-O-N-R-A-D. Inside the continents at around 30 kilometers depth. Inside continent at around 30 kilometers depth. Upper continent from the lower continent. Called as Conrad's discontinuity. So these 6 names you should know where they are. If I draw this on this one, एक यहां पर है between the crust and the mantle, एक यहां पर है middle and inner mantle, एक यहां पर है, एक यहां पर है, and there's one inside the continent here. Inside the continent, this is Conrad. This mantle and crust, this is Moho. We don't have a name here. यहाँ पर नाम नहीं. Upper and middle, but middle and inner वाला नाम है. This is Repiti or Birch. This is Gutenberg and this is Lehman. I don't know what you guys feel, if I'm fast or slow or whatever. Okay. So this is more like a magnanimity from my side. जो GS में होना चाहिए, मैं पढ़ा रहा हूँ ऑप्शनल में. Okay. The logical beginning. I can't miss this, but I can't go slower than this. Yes. हाँ, तो वो next वाला discussion होगा. The concept of asthenosphere is not in this classification. We don't have one. In Ali, we don't have a name between the upper and the middle mantle. So Dheeraj, yes, there is one technical problem, and it's not my problem, it's actually Microsoft ka problem. That's one reason why our videos have, okay, not working right now. Allow me some time, we're working on it, it should be done. And all those who are scared कि आपका expiry हो रहा है 31st October को, whatever reason, we'll extend the expiry date for all, don't worry. So please be patient, there is a technical problem, not that we are responsible. So if you want to blame somebody, blame it on Bill Gates. Okay. So Microsoft की कुछ softwares में there is a glitch. Okay, that's why last 3-4 days we are having some problems. So our storage is with them. Okay? Don't worry, we will not let that impact you. Acha, for all those who joined today, every Tuesday and every Wednesday we have case studies. Okay, today will be the last case study for agriculture. The topic I would have taken as a part of class, which is a poultry वगैरह discussion था, Ajay sir will take. And this case studies take 15-20 odd minutes. Sit back and attend it at 2:30. So online you can join from the link itself directly at 2:30 today and tomorrow. Okay? I'll continue tomorrow.